Under task and utilities, under task, under linear models, binary logistic regression is number 6 in the list. Double click on it to open it up. We are using the same HEART2 data set. Now under roles and the response, our response of interest or the outcome of interest is chronic heart disease, CHD. And the event of interest, we have two values, chronic heart disease and no CHD. So we are interested in seeing the probability of chronic heart disease. Our classification variable, let's choose sex as we did in the previous example. And among the continuous variable, let's choose number 1, the cholesterol level. Now we do not have the age of our participants, but we can use age at the start of the study as a proxy of age. So hold and press and hold control button and click on age at start. Click OK. On the models tab, we're going to keep all the main effect models. We do not want right now the interactions. We just want to keep the things simple, at least at this stage. The selection, we are not model building, so I will leave selection method as none, and I will just go ahead and submit the code. Okay, so here are the results. The most important table here is the odds ratio table. The one here, we have the sex female to male as 0.443. The way we interpret it is as follows. The probability of developing chronic heart disease for females compared to males is 66% lower. So the odds of developing chronic heart disease for females is 66% lower than that of males. And for age at start, because it is a continuous variable, so it is the change for each unit increase in the age, and the value is 1.049, and we interpret it as follows. With each year increase at the start of the study, the odds of developing chronic heart disease increases by 5%. And for cholesterol, the value is 1.08, which is interpreted again as follows. The odds of developing chronic heart disease increases by 0.8% with each unit increase in cholesterol level, holding age and gender constant. Yeah, that's an important thing which I missed with males and females. All these values have been calculated with age being adjusted and cholesterol suggested, and for age, gender, and cholesterol is adjusted, and so on. In the table above, we have the values in log R's, which are difficult to interpret as such, but just wanted to show you that with the system first converts the model into log odds and then make the inverse of it for our interpretation in the next table. Another important thing to note here is the p-value. We see that all our variables have p-values less than 0.05, meaning that all these three predictors are statistically significantly associated with chronic heart disease. Another important thing to note is the confidence interval. In case of categorical variables, our neutral value, as we have previously discussed a couple of times, is not 0. So neutral value in case of categorical variables when we are comparing proportions is not 0. The neutral value is 1, because if numerator and denominator, both of them are the same value, we will get a neutral value of 1. But if one of them is different from the other, we will either get above 1 or below 1. So the confidence interval in that perspective is interpreted as follows, that the confidence interval does not contain 1, so this value 0.43 is statistically significant. Similarly, for age at start, the range is 1.041 to 1.05. Again, this range does not contain 1, So this is statistically significant. For cholesterol, again, very close to 1, but still it is on one side of the number 1, 1.006 to 1.009, meaning that the odds of developing chronic heart disease where each unit increase in cholesterol ranges from 0.6% to 0.9%. We can interpret other tables by pasting them in ChatGPT. I'm not going to do it over here because it might take time, but you are most welcome to paste all these tables in ChatGPT and get the precise interpretation of all these tables. But again, the most important table in our binary logistic regression is this one, although we also look at the p-values for the log odds. I'll see you in the next video then.